So, no last names. Next lesson then, right? Since we have no homework. Have you read through this lesson at all? You have not. Okay. Boy, if I could lay it out as well as I did yesterday, I should have been recording that one. I'm going to talk to you like I'm talking to a whole class. There's one person in here. But I'm going to try to do it as well as teaching the entire class. Otherwise, I just sit down and write it on paper and show it to you. It's pretty darn simple in a way. It involves some new ways of looking at an old topic. So we start out with our vocabulary. It's mean and median. Those are the first two things. So you remember the difference between mean and median. Median, like the middle number. Mean, you add them all up and divide by how many you have. Okay, so now we're going to show you a different way of doing that using sigma notation, which is also part of the vocabulary. So let me write this out. Center of data. And weighted averages. So the big thing here is how we write out calculating a mean. So we're going to start out, first of all, with sigma. And when we use a Greek capital letter sigma, that's summation. So this is also called summation notation. Summation notation, sigma notation, or writing the letter sigma notation. So if we write out that we're going to add, like 5 numbers. So let's say we have these numbers 1, 3, 4, 2, and 8. If we wanted to add those up, eventually we'll look at how we write out the mean of those. But if we add those up, there's 5 terms in our set. And when we write with sigma notation, what we will have is generally we say I is equal to 1 lowercase on the bottom. And what that means is that we're starting with, in this case, the first term. So here the first term is a 1. And then we write something up above here. In this case, we have 5 terms. So we would put a 5 on the top of sigma. So what this means is that we're summing the first through the 5th term. So we could add the third to the 5th if we wanted to, or the second to the 4th term. So we can take subsets of this sample. But for now, we're just going to say that we're adding the first through the 5th term. And we're saying that the variable x represents each of these terms. So x could be 1, could be 3, 4, 2, or 8. And when we put a subscript I after it, that allows us to say, well, we're going to use the first term, which would be x sub 1, and then the second term, which would be x sub 2, and such. So the meaning of this in an expanded form is really x sub 1 plus x sub 2 like this, x sub 1, 2, 3, 4, all the way through to x sub 5. So that's, in this case here, it's adding 1, 3, 4, 2, and 8. So that's going to add up to being, what, 18, if I'm not mistaken? So this is a long way of writing that we are adding those numbers. Now, what would you do to this if you were going to find the mean?
Divide by 5.
Divide by 5. Divide by the number of terms. So if we're going to do the mean, we get, this would be 18/5, so 3 3/5, or however we want to look at it. So what we would have to do is this here, we're going to be dividing by the number of terms. And if we came back to this here, we're dividing by that number of terms. And if we wanted to do the mean here, we could say that we're taking all of this and dividing it by 5. So that's kind of the application of doing it with 5 terms. Now, in general, how do we write this? Well, here's how we write it. We write the sum. It's going to be like this. the sum of the first n terms, n's the variable, can be any number of terms that we have. It could be 2, 10, a million, whatever. In this case, we have 5. This is saying that the sum of all of the terms from the first to the nth with the variables given to each of the terms is equal to x of 1 plus x of 2 plus x of 3, dot, 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 until you get to the nth term, x of n. And that's what we wrote up here. So then, I guess this here box, that should be something that you kind of keep handy on a cheat sheet. Use it for quizzes, tests, studying, what have you. So this, it's kind of like a formula in a way, but it's a form of notation. So then if you're going to do the mean, we write that, I'm sorry? So we write that out the same way here, except it's going to be divided by n, because we divided by 5 here, the number of terms. So all we have to do is say, it's the sum of the first n terms divided by n, or most commonly, the way they do it, they don't like to use division. They like to use multiplication by the reciprocal. So we can say 1 over n times the sum. This should be a little bigger. There we go. So that's how we calculate it. That's the notation that's given. So that's sigma notation. And then, of course, we can do more with it. It doesn't just stop there. We have to make it a little bit more interesting. So let's see. Wacky widget company problem. So they give all these salaries in thousands. At 15 employees, newspaper article says $78,000 is the average salary. So what do you think? Is that a median or is that a mean based upon what you see in front of you? Mean?
Median.
How do you know it's a mean?
Median.
How do you know it's a median?
Because it seems like there are a lot of small ones that want to drag it down. Seems like it makes sense that chopping it off on either sides would kind of put it in that 90 to 65 range.
Okay, so if we chopped it off on either side, would we land on one of the incomes?
Yeah, we would.
Yeah, we would, because there's 15, so you'd have 7 and 7, and then counting 8 to either direction. The middle term would be, and there's no 78,000, is there? So that right there tells us it's got to be a mean rather than a median. Now, why would people be upset? Some of the workers be upset there. They said, oh, the average salary is 78,000. How many people make 78,000? 1, 2, 4. 4 people make more than 78. Everyone else makes way less. So what's going on is it's kind of skewed because of, it's dragged way over because of the CEO and the vice president being really high up, which is pretty typical in American business. It's very typical. That's why they put this in here. Many, many, many corporations. The top of the corporation makes a lot of money. And then there's all the other workers. So just reporting average salary and using a mean isn't very good. You could use a median and you'd come out much closer to what an average salary could be pictured as here. Okay. let's see. Okay, the next example requires us to use the idea of weighted averaging. And I'm going to go back to the book for this. Am I? Shoot. I'm feeling like there's supposed to be a problem in here. Okay, I'm just out of order. I'm out of order with this and remembering what happens. This is going to be the next one that we're going to take a look at. This is weighted averaging. And we can refer back to the book, but I want to put it all up here on the board and try to explain how we work with this. So when we do weighted averaging, we're saying that not each term has the same influence. Some terms will have a more or less of an influence. And actually, maybe a good way to do that is to jump around in the order of the book. I think that we should look at the grading problem first, because the grading problem, it tells us a little bit more about something that we can relate to. So now I'm going to second guess myself again. Excuse me. Now let's stick with the parking lot. Let's talk cars. So what they're saying here with the second example is that there are 46 cars. And 46 cars pull into a parking lot, or into a parking garage, something like that. And each car has a different number of people in it. So if you can picture, the first car that pulls in might have 4. The next car that pulls in might have 2. The next car that pulls in might have 1, and so on and so forth. And what we can do with this is we can come up with the sum of the number of people that are in the cars. And that would be written like so. And instead of using x, what we could use here is we could use p. So p sub I represents the number of people in each car. So if this is the first car, this would be p sub 4, and then it would equal 4. I'm sorry, p sub 1, which would equal 4. This is p sub 2, which would equal 2. This is p sub 3, which would equal 1. So that's the number of people that's to count. And this goes on all the way down here until you get to p sub 46, however many cars there are. So if we rewrite this, I equals 1 means that we're beginning with the first car. The n is 46, which means that we're going to count all 46 cars. And then p sub I is going to be each of these cars that gets added together, or that the numbers get added together in terms of how many people are in them. So what we could say that we have p sub 1 plus p sub 2 plus p sub 3, all the way till we get to p sub 46. So this notation means this right here. So if you wanted to know the number of people that were in the 41st car, that would be represented with p sub 41. Now let's talk weighted averages. Okay, so here's the scenario which is given. So they've got a school which is a little different than what we do here, because we don't have different classes with different numbers of credits unless it's just a semester versus a year. So for us, what's a semester class? It must be something.
Personal finance. Personal
finance is 1 semester? Okay. And then FST is a whole year. So if you took a person that has like a B in personal finance and an A in FST, because in our school the B is 3 points and the A is 4 points, those two classes would not average out to being 3.5. Because the A in FST has twice as much influence as a B in personal finance. So what they're showing us here is they're showing us, for example, keyboarding. Keyboarding is worth 1 credit. AP Calc is worth 5 credits. So in this case here, AP Calc is going to have 5 times the influence on your GPA as keyboarding does. And Honors English is going to have 4/5 of the influence of calculus on your GPA. And you know, just go all the way down. You know, the art history is going to have 3 credits, so that's going to be 3 times the influence of keyboarding, but yet it's only 3/5 of the influence of calculus. So for this example here, they say that this girl has all 5 of these classes, and these are the grades that she gets. And based upon these values for each letter grade, this is how many grade points she gets. We're supposed to figure out what her GPA is. But we can't just add all these up and divide by 5. And the reason we can't do that is because calculus has to count as 5 times as much as keyboarding does. So the calculus is like a fraction of all, when you think of it that way, or any one of these classes is. So in this case here, calc is 5 out of a total of all of these credits, which is, I think it's 16, isn't it? 9, 10, yeah. So the calculus influences the grade 5/16. The keyboarding influences the grade 1/16. So there's a number of different ways that we can write that. And it has to do with weighted averages. So what we'll do is we'll write the numbers the way we would do the calculations. And then we're going to go to what the form would be. Okay, so her GPA is going to be equal to this right here. So she has 1 credit at an A, which is 4 points. So she gets 1 times 4, or 4 points. And then we're going to add to that the calc, which is 5 credits times 2.67 points. We're going to do that for every one of her grades. And I'm going to ask you to pound the numbers. And they might have them in the book too, but you can help me. Okay. And then we're going to add 4 multiplied by the 3.33. And then our next class, art history, is at 3. And she got a D minus, 0.67. And then 3 credits on stats, which she got a C, which is 2 points. So now what we have to do with all of this is we have to divide by the total number of credits, because what we did is we multiplied everything up. So we end up cumulatively having everything multiplied up in pieces 16 times. So in this case here, we've got to divide by 1 plus 5 plus 4 plus 3 plus 3, which is 16. So what is all that when it gets multiplied together? Does it show us in the book?
It shows in about.
Okay, so what is it about?
2.42.
2.42? Mm-hmm. But that's when it's all said and done divided by 16.
Oh, that's when it's all said and done, yeah.
Yeah, okay. Well, what's 2.42 times 16? Or you're punching them all out? You're a star. $38.68. 38.68. All that on the top, divided by 16 comes out to be about 2.42. So that's how GPA gets calculated. So for example, in college, I have like 55,000 credits. I don't know, it's something crazy. No, I don't have that many. But I have hundreds and hundreds of credits. But some of my classes were 1 credit, some of them were 5 credits, some of them were 4, and so on. And they don't all weigh evenly. So when they calculate your GPA, when you have different numbers of credits, this is exactly what they do. So let's see if we can come up with a notation for this. So we added all these things here, so we can say some kind of a sigma. And we started with the first, and we ended with the 5th, and we added up her grades all the way across. Let's see what the notation is that they used. Oh, they just call them X's. So her grades are all variables. But then we multiplied by the weight. And in this case, the weight was the number of credits. So the weight for the first multiplied by the grade for the first. The weight for the second multiplied by the grade for the second. We added all of those up. So what this ended up looking like was that, up on the top. Then we divided by this. So where did these numbers come from relative to what's up on the top?
The sum of the weighted.
It's the sum of all the weights. So we divided by the sum of all of the weights. And that's this right here. So a weighted average looks like this. Oops. So it's the sum of the weights times the grades divided by the sum of the weights. But you have to do all of this work first. So there's order of operations. And all of this work involves multiplication and addition. So you got to get all that done. You got to get all this done. So there's no canceling. Because this summation is a whole process in and by itself that requires multiple steps. And when you see it expanded like this, you can see that I can't just cross out the 3's like that. You can't do it. You can see with the multiplication that that has to get done first, and then you do the addition, and then you can simplify. Okie dokie.
You know what's interesting? Is she has a B minus in AP calculus, not just calculus, AP calculus, yet at regular level statistics she has a C.
Yeah. Some people fall asleep in C, or in statistics and get a C. Here we are, this is statistics. Some people like it more than others. There are people that die for this stuff. There are people that fall asleep in this stuff. Okay, so let's see. We've got one more here that I'd like to look at with you, talk about. And what they're having us do here is convert a frequency table and a graph for concert tickets to relative frequencies. So, let's see. When they give it to us, they don't give it to, yeah, they do, that's right. They give it to us out here. So this is the frequency table, because a frequency is simply a count. And it's done by category. So $20 tickets cost, or there's 1,000 of them. $30 tickets, there's 500. $100 tickets, there are 20 of them. So this is a frequency table. It's just a count of how many there are. We did a lot of these back in 8th grade. Here's a frequency graph, where we take those numbers and we just put them on a bar graph next to one another. And if you take a look at that, you can see that the influence of the $20 and the $30 ticket is much greater in terms of what the average price of a ticket would be than the $100 ticket. because there are hardly any $100 tickets. So what we need to do is we need to turn these into relative frequency. So relative frequency is the number within a subset out of the whole. Because what it is the relative frequency is relative to the whole. So in this case here, the $20 tickets relative to the whole of the tickets, relative to all of them, is 1,000 out of 1,520. So relative frequency is like a percent. But in this book, we're going to find that it's decimal. They don't do it as percents too often. So frequency is a total count. Relative frequency is a portion of the total. So the $20 tickets will be 1,000 out of 1,520. So those are your $20 tickets. The $30 tickets, there are 500 out of 1,520. And then the $100 tickets, how many are there? 10 or 20?
20.
20. There's 20 out of the 1,520. So this is the relative frequency. The book says that it's about equal to 0.66. This one, it says it's about equal to 0.33. This one, they say that that fraction is about equal to what? It's a real small number. Scroll down. 0.01. This is about 0.01, so it's about 1% of the tickets. So if we take that information and we put it into a table, the relative frequency for the price is, what they do is they give the fraction in the book, and then they say it's about 0.66. Here's a table. So this would be a relative frequency table, because it's relative to the whole. And what's given initially in the book is the frequency table, which is just simply a count of everything.
Oh.
So these are like percents, but it's written as decimal numbers. And then if we graph this, and we'll just look at what they did in the book. Oopsies, I didn't do that. There's my relative frequency table, same as what's in the book, in the lesson. So if we look at this here, here's a bar graph. So they top out at 1, which is the same as 100%. So here's your 66, your 33, and your 1%. So that's step 1. Now we got to find a weighted average and find out what the average price of a ticket is. If we used the median, it'd be $30. Which, I don't know, that's not so bad. It's still a little high, I think, because of how many $20 tickets there were. You know, 2/3 of the place is $20 tickets. So I bet that the weighted average is probably not even $20. So what I did over here is when I wrote this out is I started out the weighted averaging. Here is the fraction of the tickets at $20. So if we multiply that out, add it to this being multiplied in this, that gives us a weighted average. Because the fraction is the weight, and then this is the price. Here's the weight of this one. This is weighted at 500, 1,520 times $30. So this is kind of like the grade, and that's the number of credits, or the fraction of the credits. And we do that all the way across. So if you do that math and you multiply it out, it comes out to $24.34. Just be careful when you're doing the math with that. If you do it on a calculator. And I guess this one isn't too bad, 20 times 100 divided by, or you can always just simplify, have less digits. So that's weighted averaging. This looks a little different than the last problem, but it's essentially, algebraically, it's the same thing. Question? Ready to give it a try?
Mm-hmm.